Okay, it's 12 o'clock. Yeah, time to start. Out of curiosity, how many of you have already used R integration? Not too many, it's good. If you have, so what this talk is going to do is we're going to talk about just some cool demos. So if you haven't used R integration, you'll get to see sort of some interesting things you can do with it. If you have, this will hopefully be things you've not done with it, because they're kind of weird. We'll also talk about how to use it and make it fast. What are some issues of performance that you might run into, and how can you get around those? Then we'll also start digging in and trying to understand what is R integration, what actually happens when you send data back and forth between Tableau and R. We'll also talking about controlling the return values, sending more or less data than what you sent. This is where we start really getting into and really extending the what it was built for, like going much further than that. And then we'll also talk about R integration on Tableau server. So let's start off with then, cool demo. Got to start off with story, motivate everything. So what these are all zebra mussel sightings. So zebra mussel looks like that. It's a tiny little mollusk, shellfish mollusk that attaches itself. It's not native to the United States, invasive species. So it just spreads all over everywhere. It spreads all over your boats. So if you're trying to, bring a boat around everywhere, it'll just clog your boat. It spreads itself onto other native mussels, so sort of taking over and forcing them out of the ecosystem. If you're in Minnesota, Wisconsin, et cetera, you know about it because it's a really big problem. And so we'd like to track it and actually see how is it spreading so we can try and limit the spread of these zebra mussels. So this is good. We've got some data on this. The data here is latitude, longitude, and date of a whole bunch of zebra mussel sightings. So we should be able to use this to sort of track the spread of zebra mussels across our states. However, missing from this data is state. We've got the latitude and longitude, but we don't have the state. And if I'm in Minnesota, I probably don't care about the zebra mussels in California. They're not really going to travel across the Rocky Mountains and invade Minnesota. So we'd like to filter down just to the ones that are in states near me so I can look at them, but I don't have state in my data. What could we do? Well, one option, we've got the latitude and longitude. We should be able to figure out the state just from the latitude and longitude. We just want to turn all of those latitude and longitude values into states. You could do this in a pre-processing step. Anyone from Alteryx? Oh, we got an Alteryx person. Alteryx has the ability to do that, right? Yeah. There's other things that you can do just before you load the data. You could even use R to try and figure out before you load the data which one belongs to what. But if you already loaded the data into Tableau and you want to do it right there on the fly, maybe we could try using R integration to try and do it directly in the Tableau workbook. Now some people might be saying, wait a minute, I know what R is. R is a programming language for statistics and graphing. That's not what we're talking about here. Yes, primarily what R is for is statistics and graphing. That's what it was built for. All of those graphs were made in R, and they all are very statistically related. Trend lines, cool correlation scatter plots and clusters, that sort of thing. But it is open source. And one of the cool things about open source is if you get a really active community, you get packages on anything. There are over 7,000 official packages for R, and that's because R has a really active community. Mostly statisticians, but all sorts of other things as well. For instance, there's textual analysis, all sorts of interesting NLP sorts of things. One of the coolest examples that I've seen for R integration with Tableau is taking a whole bunch of tweets and trying to determine was this a positive tweet or a negative tweet. That's not showing up on your sheet screen. A positive tweet or a negative tweet. What are people saying about your product? There's even a package on Minesweeper. I don't know how you'd use that with Tableau, but a challenge, try and use R integration with Minesweeper and Tableau. So all of this maybe would convince you that we really might be able to use R then to try and figure out which state all of our latitude, longitude values belong to. So that's the idea. We're going to take all the latitude, longitude, put it through R, and get the state out. All right, time for the demo. Make it bigger. So that's the original data I was telling you about. And I've just got R state. I'm going to drag this onto color. Ah, it worked. I'm just flagging for every single point on the viz which state did it belong to. So now I can say, well, what do I want to keep? Do I want to keep all of the zebra mussels that aren't in any state, Great Lakes or whatever? Let's exclude those. Let's take, how about just the ones in Wisconsin, Minnesota, Michigan, that's good. Iowa, let's only keep those. And we filter down just to the states that we care about, the ones that are near us. But this is Tableau. Let's add some more interactivity, some more spice, and add year to the pages shelf. And now very quickly, I can start seeing the spread of zebra mussels over time and see as they invade the Mississippi River and start moving further down and up the Mississippi River. This would be hard to do just in R because you'd have to create a whole bunch of code to make the interactivity, to make the colors and formatting, make the map. It would also be hard to do just in Tableau because you'd have to figure out how to get state. Bring the two together, we're able to get the interactivity of Tableau, but all of these packages from R. All right. How did that actually work? What actually happened in that calculated field that I just magically brought on? How do you know that just wasn't state? So what did I do? The first thing I did is I went and I just Googled that search term. Actually, for a while, I tried writing it myself and then determined that I should actually explain it to you. So I Googled that search term. And what did I find? My first result was Stack Overflow. I'm like, oh, great, this is good. That's a good first hit. And what did I get? I got, is there a way to send latitude and longitude and get state? That's exactly what I was wondering. This is good. My Google Foo has provided me good results. Do they have an answer? Here's a function that takes a data frame of latitudes and longitudes and uses over to return the state. That's exactly what I was looking for. Thank you, Stack Exchange and Josh O'Brien on Stack Exchange. This is the code I was looking for. So we take that code that he just provided there in my answer, and we put that into a calculated field that looks like this. This is how you interact with R integration. You get to put the code, the R code, directly in the calculated field, and then it's going to run R code. Let's look at this in a little bit more detail. You have 4 functions that you can use that will talk to R. Script string, script int, bool, real. Script says that's going to be a script, go talk to R, or Python now if that's what you're using. Then the second part is what is it going to return? In this case, we want the name of the state, so you want script string. The next chunk is just R code. You get to put R code directly in the calculated field. As far as Tableau is concerned, it's just a string. You can write whatever you want, use whatever packages you want. It's just going to treat that as a string. Except that anywhere it sees .arg1 or .arg2, it's going to take your data from Tableau and shove it in. So if it sees .arg1, it goes and looks at the data from Tableau, which are your other arguments, grabs .arg1, the first argument, and says, I found that in the code. I'm going to take this data from Tableau, shove it in place of .arg1. .arg2, similarly, go and take the second. You can have as many as you'd like. If you actually manage to push it and actually get some sort of error, I haven't managed to yet. So as far as I know, you can do as many as you'd like. So that all turns into a calculation that says, send this to R. So let's look at how this worked in the calculation I wrote. Here's the calculated field. We've got the script string on top that says this is going to be a calculation, returning a string, talk to R. There's the R code. I'll walk through this in a bit. And down there, that's the data from Tableau, latitude and longitude values. That's what we need in order to get return the state, is just those 2 values. So that's going to take the latitude and longitude and shove it in wherever it sees .arg1 and .arg2. So a little bit more detail for those that really want to see the R code. If you're not interested in the R code, you can, I don't know, check your email or something. But first thing we do is we load the libraries. All of these things that we're going to do, a lot of map stuff, this doesn't come native to R, but there's someone else that wrote it, so we have to load these libraries so we have access to these functions. Next, we define a function, and the function takes in the latitude and longitudes and spits back the state. In that function, we're saying, go to that package, take all of the state boundaries, turn those into a data frame, which is a R object, R-likes data frames, and that's just going to be all of the boundaries of those states. Next, take the latitude and longitudes, turn that into a data frame, and then compare your boundaries of your states, your points, and figure out which point belongs to which boundary. And that's how you get back the state. And then finally, you've defined that function. So why don't we apply it to latitude and longitude from Tableau? And just like that, we've got our calculated field, take our latitude and longitude, do magic to it, and get the state back out. I promise that actually was what's happening in my workbook. So some of you might have been suspecting maybe I was hiding something under a rug, sweeping it. There was a tiny bit that I was sweeping under the rug so that I could get you a better demo. If I actually did exactly what I said, here it is, that exact calculated field from the screenshot. Let's see what happens when I drag this out onto the color shelf. Pinwheel of death. Now we've got the computing of death. Now we have some time to fill. If you saw this last year, I'm going to tell the same joke. 3 logicians lock into a bar. The bartender says, "Would y'all like a drink?" The first logician says, "I don't know." The second logician says, "I don't know." And the third logician says, "Yes." Okay, it did load, but it was about 32 seconds, right? It was pretty long. That was much longer than my original calculation. Why was there the difference? Let me see if I can explain. I have here, back here, see if I can line these up. Let me pull that back off. I've got another calculated field here that is going to print whenever it sends a call to R. Let's see what happens when I drag this onto the color shelf. Over here, we see that it's printing over and over and over and over and over again. What's happening is it's making a call to R for every single point on the viz, which is really inefficient. You could have sent all of the data on the viz over at once, and then it would have been much faster. You wouldn't have to do all that communication. How can we fix this? What we can do is we can actually come here and say compute using, by default, it's table across, which I'll dig into this a bit. That means for every single different latitude value, you're making a separate call, which means 1 for every single one. If you do across then down instead, we actually just only made one single call for all of the data. So again, what I did is I said compute using across and then down. And then it's pretty much instantaneous. Let's dig into that a little bit more. I have another example here that's more of a table, because it's easier to understand this compute using thing here. Let me clear this. I take another one. What is this one doing? This is printing both the length of the vector, how much data are we sending over, and also exactly what that data is so that you can see it. And in particular, we're printing out subcategory, which we have on our viz. If we drag this onto the color shelf, it doesn't do much on the viz, but you can come and see that we're sending vectors of length 4. That's table across. Let's open up the edit table calculation viz dialog, and it will actually highlight to try and explain what we're doing. Here we're doing table across. That means every single row is a separate call to R. It's sending all 4 values over at once. We do table down. We're doing a vector of length 17, 1 for every column. If we do across and then down, it's doing all of it at the same time, all 68. If you're ever not sure and want to make sure that you're sending all of the data, one, you can try using this sort of debugging method with print statements. Also, you can go to specific dimensions and make sure that everything is checked. Anything that is unchecked, like if I were to uncheck region, becomes a partition. And so now I've got a partition, 1 for every region. If I have it checked, there's only 1 partition, the whole thing, and so it all gets sent at once. Don't need this anymore. I already went over that. So this gets us to what I call the first rule of speed, which is try and send as much data over to Tableau at one call instead of trying to do multiple calls. And this is probably this is like the main thing that slows down workbooks. And how you do this is you open up the calculation dialog, and make sure as many things are checked as possible. So before I move on then, you might be wondering, wait, what was that? What was that thing that was printing off the stuff that was helping me debug? What this is. That was rserve. That was actually in RStudio, which is this nice environment for interacting with R. And the thing that was actually doing the printing was rserve. What is rserve? I skipped a step when I was talking about the calculations. I said, well, we make all of that code, and we send it over to R. But how does it get sent over to R? There's actually something that sits in the middle called rserve that does the communication. It knows to listen to Tableau, get that, and then send it to R, invoke R calls. So you can think about it like this. Start with all that script that we made in Tableau, send it to rserve sends it to R evaluates, sends it back to rserve, sends to Tableau. rserve is actually an open source. Other companies and projects use it as well. You could go and modify it to your bidding. It's an open source package out there. That's just a service that listens for R code. One way to start it up is, and the easiest way to start it up, is to just go into RStudio or R, whichever one you like better. Install the package. Doesn't come with R, so install the package. Once you have it installed, load the library, and then invoke it. If you invoke it using on Windows, so this is a little bit annoying, platform specific. On Windows, if you just say rserve, it'll actually start up a separate process in the background. And then if you print, you never see it because those all get eaten. But if you say run.rserve on Windows, it'll start it up right there in the console, which you'll never be able to type R code in that particular console again. You'll have to kill the program because it's taken over. But it'll start printing right there into that console, which allows you to do some cool debugging methods like that. On Mac, you can just say rserve, and then you have to put those arguments in there. The arguments, this particular set of arguments, not useful for Tableau, but you can dig into what that is. So that's rserve. That's how I got that nice, cool little console, so that if I wrote print in my calculated field, I could actually see what it's printing out and start really understanding what's happening there or what's happening in my code. It's a useful trick. Let's also, since we're talking about rserve, look at some of the other parameters. You can add debug equals true. That's another way to, instead of just adding these print statements in your code, you could start getting debug statements. Personally, I find it to be way more verbose than I need. You can find the information, but you really have to go digging for it, which is why I use the print statements personally. You can also change the port if you want to change what port you're running on. But the most important is rsconf, which you can see I've started up rserve up there with rsconf specified. That's the configuration file. So then if you want to do more advanced configuration, you can go there. And there's one configuration that I want to put in this configuration file. You can still in your configuration file do the boring things like specifying the port, allow other people to access your rserve, but you can also put a source file that allows you to put a whole bunch of code that will just run when you first start up rserve. This is really important because then if there's something that you want to run once, but not every single time you make a calculated field, you put it in this source file, tell rserve to look at it, and then you can run it just once. Why would you want to do this? Well, you might have some libraries that you want to load. You might want to have to forget which of your functions use those libraries or not. If you put those in the calculated field, you'd have to remember every single time when to use those libraries. So this is just a set of universal libraries that you and anyone else that's using your rserve would be able to have. You could also define custom functions. So then those functions are available to you every single time. So for example, if you remember in my calculated field that did state from latitude and longitude, what were our steps? We loaded our libraries, we defined this function, and then we called it. Those two things, loading those libraries and creating this function, we shouldn't have to do that every single time we make a call to R. Those could just be predefined. And then taking that data frame and defining the borders of the United States, we wouldn't have to do that every single time we made a call. So that gets us to the second rule of speed. Use that configuration file and move as much of the code as you can into that source file so that it only runs once instead of running every single time you make a call to Tableau. So take all of this and move it into the source file. So let's actually see a demo of that to prove that it really does make a difference. You should never believe just someone who's presenting to you. You should make them prove it. So here we are. You'll remember that that first time I dragged that calculation on the field, it took about 32 seconds. Here, I've moved the code out. I'm still going to use the default compute using, so it's going to do one call for every single call. But it's not going to have to load the libraries or define that function every time. If I drag this onto color, it's still going to pop that up, but that was about 3 seconds. Much faster. Yeah. So in sum, we've done one cool demo, well, two, depending on how you count it. We've talked about faster workbooks by moving your fields to addressing, basically checking all of your fields, and move all of your source code into a file. We've also looked at printing to the RServe console in order to sort of better understand what's going back and forth. So let's move on to another demo. We had a question.
So in the R script,
Yeah.
you loaded the library and you run that RServe. Did you run the source file, or did Tableau tell R to run the source file?
I ran the source file. I can actually just pull that open. So the question was, is it Tableau running the source file, or is it R running the source file when you launch it, right? Right here in RStudio, this is the code that I used to launch that, and it's specified right here in those arguments. Yeah. One more question, then I'll move on. Yeah?
So when we publish the file, we need to also install the library configuration.
So the question was about publishing. I'll talk about Tableau Server in a moment, and then remind me, and then I'll try and address that again. Okay. So I'm going to go back. Okay. So time for, all right, one more question, sorry. Yeah. Okay.
So you're using R to figure out the state by using the actual latitude code, right?
Yeah.
My question is, if you keep the latitude and longitude as data direction, Tableau should plot the states on the graph automatically.
Yeah, so I brought the,
State on the state column from the on the desktop, it actually is exclusively figure out the actual latitude dimension. So why do you have to R for
so if I get you right, you're questioning the validity of my example, which is I'm using R integration to give me the latitude and longitude. Why not just do it ahead of time? I can give you some reasons why maybe, like, oh, it's in an SQL database and I don't want to have to modify the SQL database or something like that. Really, it's a cool example. Yeah. No, I mean, you wouldn't have to worry about performance if you did the pre-processing. Yeah. But, okay. So the second story, and maybe this one will be more convincing to you. The second story is, okay, we still got the zebra mussels. We still got two different species of zebra mussels. But one thing we have is that, well, if we're trying to track the spread over time, if we have zebra mussels up at the top of the Mississippi River, and we have zebra mussels all the way down here and all the way in Louisiana, most likely we actually have zebra mussels all the way through. So what we want to be tracking is not so much the specific sightings, but actually their territory. If we were in R, there would be a nice simple territory we could use. This is what our graph might look like. But we could just do the convex hull. The convex hull just kind of takes the most outermost points and then draws a polygon around them. Simple way of thinking about it. Okay, so apparently, theoretically, anything we can do in R, we should be able to do in Tableau. So let's see. Oh, there it is. Yes, I'm actually getting the convex hull from R and plotting that here. And I can just take, well, there's two different species there. I want to plot those outbreaks separately. I can just take species and down here and drag that onto color. Very quickly, I can say, well, it's plotting one on top of the other. Let me rearrange this. So now it's plotting the correct one on top of the first one. I can also say, well, again, I don't think those California ones are the same outbreak, so I can create different ways of defining outbreak group, and drag that on and break them up by that. And then finally, let's get some animation by putting year on the pages shelf and watching as the zebra muscles spread over time. All right, that's a fun, cool example. Let's again go and see how did that work. Here we are. What we're trying to do is we're trying to get the original points and then just return the points that define the convex hull, and then Tableau will draw the polygon for us. So what do? We have we just take the latitude and longitudes again. I put in year. You don't actually have to put in year. But you put in the latitude and longitudes, and you combine those into a data frame. R likes data frames. Then you just apply the C-hull function to that. C-hull just says convex hull, gets the convex hull. And then finally, you pull out the latitude from the convex hull. Except that's not quite what I'm returning. There's a little bit more here. There was about 3,500 points in my original data set. The convex hull is only going to be 7 points. So getting to why I used that example before, the example before where you had latitude and longitude and it was just giving you state, that works very much like how our integration is supposed to work. You're just thinking about this as another field in your data. So you've got latitude, longitude, and state. For every latitude and longitude value, you've got a state. It fits into your data structure very nicely. In this case, that's not what we're doing. What we're doing is we're trying to just pull out 7 of these points and return just those 7. So how do we make this look like a part of our data? If we just have this 7 points, it doesn't look like just another column. What we can do is we can just sort of tell R what I want to do is put it at the top, and then take that last point and repeat it over and over and over again so that it's the correct length. So here you can say, well, this is 1 point, 1 point, 1 point, 1 point, all the way around. But this is actually 3,486 points all on top of each other. But if you still make a polygon out of that, it still looks like a polygon. So what are we doing? We're taking the original data, the latitude, but then we are repeating the last row of our data over and over and over again in order to pad and get that. We only have to figure that out once, though, right? Because once we figure it out, we can define a function to do that for us, put that in that source file so that we have it available to us. And then I've just created this. It's actually much more complicated than what you would need to do. Just this tab return function that says if I put first in there, then that means take the first value and repeat it. If I put last, take the last value and repeat it. So then you only have to figure out how to do that once, and then you're good. And that will allow you to return as much data as you'd like, even if it's too short. So this is a technique. If you want to return less data than what you sent, pad the output with extra stuff. This can be zeros. In this case, I'm padding with like the last value, and that'll work for convex hull or polygons. If you're doing something else where you're going to be trying to return something too short, maybe you'd want to return zeros or -1 or something that indicates this is dummy data, and then you can hide it afterwards. So that's technique 1. And moving that. So far, summarizing where we are. Cool demo, how to make your workbooks faster by moving fields to addressing and moving things to the source file. Then we also have printing to the console to understand what's happening better. Return fewer data. So that leads us to the natural next step. What about returning more data? Returning more data is harder now because you can't just pad. So let's give you an example so we can sort of get the concrete thing of what we're talking about. Concrete example, definitely not absurd in any way. You've created a new bear spray, new fancier bear spray, better than any bear spray anyone's made before, still made out of pepper, but fancier pepper. And you want to figure out when should I launch it so that people are thinking about this and will pay attention to what I'm advertising. So let's look at what kind of data we could use. Problem, when should I advertise? Well, we've got some data, Google Trends. Google Trends is cool because you can find out when are people searching for bear spray, when are people thinking about it. Is there some seasonality to it that I could predict? This is when I should do it. They give you a date and how much search volume was there for bear spray during that week. We're going to do it by week. It looks like this. And it looks like there is seasonality to when people are interested in bear spray, which is interesting. So if we could get a nice forecast, we could probably forecast when the best time is for looking at bear spray. So you could use built-in Tableau forecasting, but there might be reason that you'd want to use R forecasting instead. You understand what's happening in R. You can put more considerations into it, so instead of just the date and the volume, you might have some other knowledge of when people are going to be looking into that you could build into your models. So let's look at how we'd use the R forecasting instead of just the Tableau forecasting. So this is what the calculation is going to look like. First attempt at calculation. We load our library, as always. We define our data. We've got flu symptoms, that's going to be coming from here. That's the search volume. And then we've also got the start date. That's the date that we're going to be using. We turn that into a time series, which is another object in R. And then we actually create a forecast on that time series. And then what are we trying to return? We're trying to return the forecast. So this is going to return the mean forecast value. But this isn't going to be quite right. The mean for our original data, we had about 5 years of data that we're starting off with. The forecast is only going to be 2 years by default. So again, we've got this problem where we sent 5 years of data, and we're trying to return just 2 years of data. And it's not like we just want to pad it. What we really want to do is return all of it. This is what we're trying to visualize, both the original and the forecast together. In the R code, that's not too bad. We can just append the two vectors, the original vector and the mean forecast together. So that's how you get the R code to try and return all of that. But that doesn't mean that Tableau is going to accept it. So the other thing that you've got, you're trying to return along this date. Your original date, only going to be 5 years. How are you going to get that extra 2 years on there so that you can actually return the full set of data instead of just the 5 years? Here's a calculated field that will do it for us. Basically says, if you've got the last data point, if it's the last date in your data, just add 2 years to it. Otherwise, just use the original data. That's one option. You could actually add another data in your raw data if you wanted. I like this result because it just allows me to add dates dynamically without changing any of the underlying data. And I could change that from 2 years to any length I wanted using parameters. So let's actually go and look at that. So here I am. This is the original data. Here is the forecast date. This has the extra 2 years added to it. I can grab this and replace my original week with that. And let's go back down to the week number level. I've got two extra years in my data. So now if I take my forecast and drag this out in place of search volume, it returns the extra date. There is a little bit of a thing I want to point out here. In here, I have show missing values selected, and that was automatic. And that means it's actually filling in those dates with dummy data. That's a little bit more easy to see if we were using a discrete date instead of a continuous date. So let's go and look at that. Here we've got the discrete date, and show missing values is not selected. But if you look down here, this last the last data point, if you say show missing values, goes all the way out because it tries to show you all of those missing values in between. If show missing values is not selected, that collapses down. It doesn't show you everything that's missing. So if you're having problems with this, you come here and say show missing values was not selected. On a continuous viz, it looks the same because of how the accesses work. But if you try to drag the forecast out and it's still telling you that you have too much data, try coming up and say show missing values, and it'll fill it in. So then you can also return not just the mean forecast, but upper confidence intervals, lower confidence intervals, stuff like that. One other thing, though, is when you did the show missing values, that also meant that the data that we're going to try and send to R is also that same length. It has the extra 2 years in it. And that meant that we actually have 2 years of nulls. And so you need to modify your R code just a little bit to account for those nulls and remove them. But there's just a function called na.omit that gets rid of all of your null values. So I'm not used to Mac, where if I don't exit out, it does weird stuff if I don't close the PowerPoint every time. But you just put na.omit, and that will also remove those NAs. So just to summarize the steps that we had to do to get this returning more data, really pushing the boundaries of what this was built for. You create the script calculation that tries to return everything. Then you have to create a field that's longer with extra two years on it so that you've got something to return along. You can make sure to use that show missing values so it actually is sending all of that over. And then finally, you may have to filter out results in R to make that all work out. So that was a very reasonable traditional example, except for the theory as to why you're doing it. Let's do something a little bit more extreme. We still have time. So we're going to do another returning more value, but it's a little bit more fun. You look at this. Maybe it's not clear. Anyone know off the top of your head what this is? A map? Yes, all right, thanks. How about now? Flights. Everyone just knows, right? Yeah, and you might even be able to see Austin Airport. These are all of the places where we have direct flights out of the Austin Airport out. If you're doing data visualization, you might know that removing how much time you have to figure out what this viz is about is important. You're trying to plot an escape from ravaging, man-eating rats that have invaded the city. That time matters. So, but if our original data is just the locations of all of those airports, how are we going to get enough points to make this nice curved line? We might need, as many as 20 points to make a nice curved line, or, as many points as you'd like. How are we going to get enough data to do that? There are certainly functions in R that would do it for us. We're going to use this function called GC intermediate. What it does is it just takes in a starting point and an end point, and then it will find the great circle and all of the intermediate points along that line between the two latitude and longitude points you give it. So what are we going to do? We're going to load our libraries. We'll give it the two starting points, the latitude and longitude from our data, that defines the airport, and then the latitude and longitude of the Austin airport. We say, give me 20 points. We'll actually control that with a parameter so we get all of the interactivity we want, make it curvier, and say, give me this many points in between, and then give me the latitude. Try and return that. But again, we've run into a problem, right? We only have 1 point in our data, and we need 20. How are we going to do with that? I'm going to demo this in Tableau. All of the visual. So here it is. This is my original data. If I hover over a point, you'll see that I only have 1 data point right there. How am I going to get a line? Well, there's one way I could get 1 more point. I could come to Austin Flights, that data source, and take another copy of the data and add it to the data. Now I actually have, so what that was union. If you're still on 8.0, you might not have seen that yet. You take 1 copy of the CSV and union another copy right on top of it. You could also union as many copies on top of it as you'd like, but that doesn't sound like fun. Let's see if we can do something fancier. Well, now we have two copies. This at least gets us somewhere. So this is our data now, shown a little bit differently. We've got each of the airports, latitude and longitude values of those, and we've got Austin Flights, the original copy, and Austin Flights, a second copy. What if instead we created a calculation that says, if it's the original copy, give me 1, and if it's the second copy, give me 20, or however many points I want to use. And we'll call that point ID. So if it's terrible. If it's the original one, if table name is austinflights.csv, give me 1. Otherwise, give me number of points. Drag that out onto the viz in place of table name. Now I've got 1 and 20. My number of points is set to 20. This is promising. But it still doesn't give me, if I right-click on this, I don't have show missing values. Tableau does not, by default, on all of your fields, give you this option. Dates, yes, and there's one other type of field where it does show missing values, which if anyone know off the top of their head what field that is? Bins. If you're doing a histogram, you need to show missing values, right? So bins also has that option. Also, it's not in this broad data, it's later on in the pipeline, so it gives us more options about what we can do. So if I were to right-click on point ID and say create bins, just like we were making a histogram, bins of size 1, now I can drag those bins out onto the viz, and I've got values from 1 to 20. So now I can actually return 20 points, just like what I wanted to get those nice curvy lines. So I've already got the calculated fields in here. These are that R code with the GC intermediate, Great Circle Intermediate. Just drag that in place of latitude, and that in place of longitude. And it's giving me curvy bar charts between my start and my end. Now let's turn this into a map. Well, we want it to be a line map. We want a different line for every airport code, so why don't we put airport code on detail? Ooh, you can already tell it's curvy. We want maps, so that means longitude should be on the column shelf. Oh, this is cool. We've got a separate map and sort of seeing squiggly lines converging on Austin, I guess. It's not quite what we wanted. We want the point ID to define the path. If I were to grab the point ID right now and add this to the path, I'm going to get an error. It's saying function expected 1 value, we got 20 values back. That's because by default, these are compute using table across, which is fine if your point ID is right there. But what we really want them to do is always compute along the point ID. So say compute using point ID bin, compute using point ID bin. Now, even if we move it around, it'll still be computing along that. So drag that to path, and we've got our map. Yeah. Okay. Okay, so that was my last demo. Now I'm going to talk about another thing I get questions about a lot, which is R and Tableau server. You know, you're a user, you've made this nice fancy workbook, and now you want to share it. Well, if you've got online and public, I'm sorry, you don't get that. But if you've got Tableau server, you try and publish your workbook to Tableau server. How is Tableau server going to be able to run this workbook? It needs to be able to talk to R and R serve, right? That's okay. You have settings that you can say, Tableau server, this is where R and R serve are. I guess it's backwards view. Tableau server, this is where R and R serve are. You can talk right here if you ever get in one of those calculated fields. All you need to do is say, this is the IP address, and this is the port that you're going to talk to R serve on. And there's, just if you look at configure Tableau server for R and R serve, there's a nice article in there on how to do it. Pretty straightforward. If you also go to that article and start reading, you'll find some warnings. R security. The following security issues should be kept in mind as you use R and Tableau together. The data channel between Tableau and R is not encrypted. RServe server does not use authentication by default. It does support plain text authentication, which, if enabled, uses a very simple mechanism that uses an unencrypted passwords list stored in a file, which, if you talk to your security people, will be like, that's not security. Why does it even bother? We didn't write this. It's open source. And remember, I am not a security expert. Please talk to your security team about these issues. But here are some ways that even though that channel between them is unsecured, it's OK. So this is what it looks like, right? You've got Tableau server. It's talking to this R and RServe instance. Don't connect that to the internet. Like, there's no reason anyone should have access to this channel. The only two things that need to talk is Tableau server and RServe. Just a direct channel right there. Make sure that's encased, and put it behind a firewall. So that line of communication, don't assume that's encrypted or safe or anything. Make sure that only those two computers have access to it. Pretty straightforward. But then you read on. R functions can contain code that can harm the security of the server where rserv is running. For example, it can access file systems, it can install new add-on packages, it can execute operating commands, it can open network connections and download files from other servers. Basically, okay, we've protected ourselves from the outside world, but have you protected yourself from your users? They can publish any code that they want up to the server. They're going to therefore be able to publish and run any code on your machine, the one that's running R and R server, that they want. So that's one reason not to put it on the same machine as Tableau server. Even if it's not like malicious, but they just accidentally start running something really long, it starts competing with resources, not good. Put it on a different machine. And then also, rserv limits its permissions. Make sure it doesn't have access to things you don't want it to. That's what's actually running the code. So if you want to restrict what your users are able to do, restrict what rserv is able to do, because that's how they're running it. So in sum, put R and rserv on a separate computer from Tableau server, limit the permissions of rserv, and open communication between the two only between the Tableau machine and the rserv machine. Pretty straightforward. But again, I am not a security expert, so do talk to your security team about these issues. And also to answer the question that was asked, well, what if the functions that you loaded in your library, as long as you, on the machine that's running rserv, make sure that those functions are there, then those will all be shared. And that's actually one of the advantages of the new tabpi thing, is it makes sharing those functions between services much easier than it was in rserv. rserv right now, you have to do that source file. If you're able to use the new tabpi service, instead you're able to, with just some commands, load functions and models and stuff to a central service. 1 second, almost done. Security on desktop, pretty easy. Whenever you open a workbook, if it has rscript in it, it tells you. You can actually look at what all of the code is, so you can just go and read it and say, do I want to run this or not? And if you say no, it won't run. You can always enable it later if you decide yes. So R integration, great R functionality and R extensibility combined with the Tableau formatting, Tableau filtering, and interactivity. It adds a lot of value to both. Okay. Thank you.